Hello everyone! A long time ago I planned to do some video about VLAs on my channel. I already did a video about inference in VLAs and VLAs on different NPU devices, but I planned to do some interesting video about training them. Initially I was planning to do training for such robot, but then I think that it's not very evil. Let's do something evil. Haha, just joking. But really, let's train a robot to kill people. Okay, not a robot. Let's train a Quake character to kill different robots, AI characters. So, let's start. Why VLAs and VLMs? Because I think that it's super important thing right now. I working with computer vision last 15 years, maybe last 10 years. Sometimes I meet robots in different projects, because robots need eyes. And for many robotic systems, computer vision is the main system. But few years ago, of course, this classic computer vision start to migrate in all this vision language action models, vision language models, and so on. And it's really drive today robotics, but it has a lot of limits, and this is exactly what I want to show in this video. If you're looking just on demos, you may look a lot of real interesting project, how robots sort objects or pouring drinks or fold towels, but a lot of this stuff is just teleoperated. A lot of this stuff, robot which is doing this, it's 10 times less efficient than old solution 10 years ago. Of course, the progress is here, and you can check such projects like BMW with Figure. It's not production yet, but it's at least something that can be production in future. So my takeaway is that it isn't like this didn't work. It's worked, but there are a few nuances, of course. What people are doing today when they want to start like with robots? Actually, there are, if you look on videos on YouTube, there are two main approaches. First of all, let's buy some super simple robot, like saw arm, for example, or something like this, or some mini Richie, or some other easy stuff. And when people starting to train them, usually all they can get it's just one or two movements, but super simple task. All these hands, they are shaking, objects grasping is not stable. Some of my friends told me that they have like 60% success rate when they trained like such arms with LeRobot. And of course, when people tested this, they usually are not very happy. The other approach, it's just some ready demo from like push T, or when people, I can run and train, it's actually work. And someone is training on some many skills emulator, some other train with Mujoko emulator, and yeah, you can look that it's achievable, but when you're trying to do the real demo, even simplest stuff is not work. And I want to show the exact moments where such networks, they are not working, what is breaking for them. It's pretty general problem for computer vision. It's general problems for classic computer vision, general problems for VLMs and VLAs, but of course it's look a little bit different than it was a few years ago. What I decided to do? As I mentioned, I decided to train bot for Quake 3 just with VLA. For now, I decided to just take the basic SmolVLA, which is like the default neural network for a lot of tasks today. I decided to train just for a few simple commands because you will see that even among these sets of commands, not all of them are working. And I decided to train with 10 frames per second. So basically I collected 40 minutes dataset. In reality, it's not even 40 minutes, it's 10 minutes, but I played Quake for 40 minutes, but I sampled 5-second intervals. After I sampled all this interval, I sampled it simultaneously with all keyboards that I'm pressing, and I push this in LeRobot dataset. And for training, I used basic LeRobot scripts. Let's check the result and let's check real behavior, virtual player. The first, what is working? This VLA learned how to navigate through the map. It's not excellent, of course, but in a lot of situations, it's actually somehow finding the way. It's finding how to navigate further. And it's actually avoiding a lot of obstacles. What is not working? First of all, when the model stuck in the wall, especially if it's stuck in the corner, it's just stuck. Why is it happen? The main reason because in my training dataset there was no such situation. And when model go in such situation, it doesn't know what to do next. So I'm just stuck in the wall. I'm trying some random actions. And usually when models start doing some random actions, then they eliminating each other and the model just stuck in. Of course, usually within a few seconds it can move out, but sometimes it can work even worse. Same problem when models start looking on the ceiling or, for example, on the floor. There was no such situation in the dataset, and model doesn't know how to behave in same situation. Okay, the next big problem. The next big problem when I'm training VLA, there is no reward function. When you training your model with any reinforcement learning, usually you prize your model for successful action. But with VLA, you pricing your model if it's copying your behavior. When there is no target, there is just simulation of really doing action. And model is totally missing why it need to shoot, why it need to collect some items. So for model, navigation is much more important because in training dataset, of course, there was some shooting on the bot, but the model figured only one logical conclusion. When it starts shooting, it's continuously spam shooting. Model totally lost out of the scope that it should shoot in people. And it's pretty nice. We are safe for now, probably. Robots, they will not kill us. The third main problem of this model, and you already saw like reasoning, like it's in previous citation with wall, there is no long memory. I'm using SmolVLA and it has only previous state. Of course, it's possible to use a few previous states, but usually for most of modern models, you're pretty limited with this state of your robot. But when you are playing some complex game, of course, you need like complex behavior. And of course, such models, they will not perform out of the box. I'm not trying to do a good model to play Quake. There are a lot of different models for this. But I'm just taking one base robotic model and I'm trying to implement it to this problem to show all consequences. And you will see the same consequences if you train any real robot. If you will train this robot, if you will train any arm, or so on. So, a few advices. If you want to train your robot, first of all, you need to specify your target success rate, and you need to choose which model do you want to take with such success rate. if you want to take VLA, it's possible option. And for some complex tasks, VLA is only the real existing option how you can train. For example, for these robotic humanoids, it's hard to create correct emulation. If you are not a big company, if you're not working with NVIDIA Cosmos or other technologies. But if you are small, you definitely can't create something like a big simulation. For such cases, VLA maybe is only one option. When you're training your robot, you need to simplify your task. So basically, just try to train robot on some super simple subset with obvious trajectories. Try to avoid these uncertainties or append them to your dataset. Try to choose the model that it's exactly for your context window. So try to append a few times frames if it solves your problem, or look at the model with a longer memory. Try to start with some simple example just to check that your general approach will work. I think that's all. And if you want to reproduce this, you're free with this GitHub repo. Also, I have an article with all links in it, so you can check this under my video. And we'll meet in the next video.